Welcome again to our channel. Today I want to show you the rectification process using the diodes. So we have got two types of rectifications. We have full wave rectification and half wave rectification. Our concern today is on full wave rectification. And why do we engage in full wave rectification? Because it is widely applicable in almost all the variety of electronic and electrical fields. So I want to highlight for you the areas, specific areas in which the rectification process is applicable in. One of the areas is the electronic motors. I think those who are concerned with the electrical or electronic are much conversant with the electronic motors. These electronic motors are automatically controlled, so they need to be some process of programming and electrical integrations. Second area is battery chargers. All battery chargers pass through rectification process, and therefore it requires a person to have this skill. It is also applicable in welding, high voltage direct current transmission, electroplating, DC powers in X-ray and radiography equipment. It is applicable in rectifier diodes, electrolysis, signal detection and demodulation in radio receivers and RFID systems. So you will realize that it is a very potential area for a student or a practitioner in electrical or electronic engineering field. For you to undertake this project, you need to have the following equipments. One, you need to have your transformer, at least from 240 voltage to 12 voltage. That is a step down transformer. We have one of our transformer here if you want to use. Secondly, you need to have diodes. These are the diodes. Yes, because we want to deal in full wave rectification, we need to have four of the diodes. And here are our four diodes. We also need to have a capacitor, at least 100 microfarad, 50 volts. Then we also need to have an LED, which is this one, light emitting diode, and a resistor, fixed resistor. So with this one I have just connected. You can connect any end of the resistor to the light emitting diode, the way I've done it. So we also need to have the PCB board, the soldering gun, and the solder itself. Yes, those are the requirements for this particular project. And also not forgetting, you also need to have the power source, at least 240 voltage, which you shall step down. So this is the process. Have your doubts? You must have to understand the diode. The diode is a two-terminal equipment. You can look at it. So on one end you will find out that it is brownish, and on the other end it is black. So the black side is the positive side, while the brownish the silver, not brown but silver side is the negative. So this is the negative, this is the positive side. You understand that the current flows from the positive side to the negative side. What do we do? In our connection, begin this way. Have a central point on your board. Place your first diode that way. Then we can solder the first diode. Then take your second diode, pin the positive side, link the positive side of your second diode to the negative side of the first diode. And this is what we mean. Then we can solder take your third diode, begin from where you came from, pin your negative terminal to the positive terminal to the positive terminal of your diode, or the first diode. That is it. You can as well take your fourth diode, link the negative terminal of your third diode, the positive side of your third diode to the negative side of your second the positive side of your fourth diode, link with the negative side of your third diode. That is the case. So you can solder, and remember we shall join them together. So you can do that, then you solder this other side. You can do it that way, then you solder. So here we have got our full rectifier. That is it. So the next thing is to connect the secondary terminals of our transformer to our rectifier So take any side, any terminal of your transformer. Any side of your transformer. Then take it to the negative terminal, and the negative terminal is this side where you see the brownish colors, the two brownish colors or silvered colors meeting. So this is our negative terminal. Then we also take our positive terminal where the black and the black merges. This is our positive terminal. Let me repeat on this. When you look at our rectifier, one end of the two diodes is silvered and the other end is black. So the black terminal, the black side is the positive terminal of our output, and the silvered side, the two silver side, will be our negative terminal of the output. The remaining two terminals will act as our input of the secondary terminals of the transformer, meaning that these ones you can fix at any point on the two terminals. So we solder. That is it. So we have linked our secondary terminals of the transformer to our rectifier. What we are remaining with is to tap the negative and the positive terminals of our DC current. So we shall tap it this way. You must understand also how the capacitor works. The longest side is the positive side, the shortest side is the negative side. So ensure that the positive side of our capacitor is pinned to the positive side of our rectifier. That is it. And the negative side is pinned to the negative side of our rectifier. So this is the case. Yes, so we can do our soldering. Yes, so we understand that the power will first be, we shall get our power from the main supply, which is 240. It will be stepped down. We receive it from the secondary coiling of our transformer. We take it to our rectifier, then we remove it from our rectifier as a DC direct current, but it will have some ripples. We remove the ripples by use of this particular capacitor. So we filter in order to remove those ripples using the capacitor, and that is exactly what we have done. So the power that we shall be getting up to this capacitor will be a very clean power. Then how do we test that the power has reached there? We connect our two terminals. Yes, the positive terminal and the negative terminal. Yes, so we solder. Yes, so we solder. Then it is over. What we do is to test whatever we have done. This is our final product. I just want to analyze everything that we have talked about from the beginning up to now. As I have said that this is our input, which is 240 voltage. It enters into primary coil of our transformer, then it is transformed into 12 voltage, which is outputted by the secondary terminal, and immediately it comes, we place it in these two terminals, this one and this. So to look at it on this other end, you will see that this will be a positive and a negative terminal held together. That will be one of our input. On the other hand, we'll also have a positive and a negative terminal, which will be another input from the primary coil of our transformer. Then the opposite terminals will be both negative. You can see this is a negative terminal, and this is also a negative, and positive terminal and a positive terminal. So here is where we gain the polarity of our circuit system. So on this end, we have got a negative terminal of our output, and on this other end, we have got a positive terminal of our output. We can identify the positive terminal by looking at the diodes. The ends of the diodes, you will see that here is silvered and the other end is also silvered. So this terminal and this terminal are rhyming, they are positive terminals. On this other end, you will see that this side is black and this other side is also black. So the black side symbolizes the negative terminal. So this will be our outputs. Coming forward, we connect our positive terminal to the positive terminal of our capacitor. And we have said that the positive terminal of our capacitor is the longest terminal. So we connect this longest terminal to the positive terminal of our diode. The negative side of our capacitor is the shortest terminal. We connect it to the negative terminal of our rectifier, which is the black and black. From here, we want to see through the LED, light emitting diode, that the circuit is complete and the power is flowing well. We use the LED, and because we cannot use the LED direct, it will glow. We apply the use of a resistor in order to protect our LED, and that is what we have done. So we can test all that we have done to see what is happening. So on connection of our power supply 240 voltage, you can see that the LED is glowing. You understand that the LED cannot glow in alternating current. It can't work. So when you see it glowing that way, it simply means that the power that is reaching at it is a direct current. Another way to see that we have a direct current at this end is by using our system here as a charger. The whole system is a charger, and therefore we can connect a DC 12 volt DC 55 amperes fan to our charger or to our system, and you will see that the fan will be moving. So we simply connect our positive terminal or the battery to the positive terminal of our fan. This is the positive terminal of the battery, and the positive terminal of our fan. I think you can see the fan is not moving because the circuit is not yet complete. Then we place the negative terminal of our fan to the negative terminal of our power source. So we will see our fan moving. This shows that we have already made a simple battery charger, and we have also rectified the alternating current into direct current. I hope you have been careful and keen on following us from the beginning up to now, and you have gained. Please, I ask you to subscribe, like, and continue watching our videos as we look forward to post more. Thank you.